the lesson video from section 11.3, the last video that we have to watch and view. And so far you've learned from the Pearson videos what independent variables, dependent variables, and mutually exclusive means. Hopefully, if you don't remember what those are, please review those videos. In this particular video, we're going to go over what it means to have events be not mutually exclusive. So what I thought we would do is we picked a problem here with chips, with tokens actually on the table. You can see there's round tokens, there's green tokens, there's orange tokens, square tokens, and we're just going to calculate the probability of each event occurring, starting with the first one. It's just one draw of tokens and the probability of getting a green token. That's a very simple calculation. All you do is count how many green tokens you have. And you can see we got 1, 2, and 3. That's going to obviously be your numerator. So 3 out of the total number of tokens, which in this case is 3, 6, 8. So we got about a 3 out of 8 chance of selecting a green token. Now, that's just your basic probability. Now, what happens if we have multiple events and we want to select a round or a green token? So what we're going to do first is just count how many of each of those are available to us. First of all, round tokens, if you count over here, we got 1, 2, 3, 4, 5. There are 5 tokens out of 8 that are round. Green tokens, there are a total of 1, 2, looks like we got 3 out of 5 of those. 3 out of 8, excuse me. So again, the review, we first calculated the probability of picking a round token, which was, there's 5 round tokens out of 8. And then we wanted a green token, which would be the color of green here. We got 2, 3 out of 8. Now, we want either the round or the green tokens to work for us, so we add those two together. Which, as you can see, gives us 8 eighths, which would be 100%, which obviously is not our probability. And here's why. In calculating both of these, we have counted certain events more than once. And this is a good example of what we call not mutually exclusive. When calculating probability and you have not mutually exclusive events, it means simply you have counted events more than once. So what we have to do is figure out which of these have been counted twice. And it would be basically the tokens that are round and green. So let's see, how many round and green tokens do we have? Well, there's one right there. Round and green. Looks like that's the only one. Oh, there's another one right there. So we've counted 2 round green tokens twice. And so what we're going to have to do is subtract that 2 out of 8 from our initial probability. So basically, again, we calculate how many round tokens there are, which of course is 5 out of 8. We calculate how many green tokens there are, which is 2 out of 8, or 3 out of 8. There's 3 greens. And then what you have to do is ask yourself, are these events mutually exclusive or not mutually exclusive? This one would be considered not mutually exclusive. These two events are not mutually exclusive because we basically counted events in both probabilities more than once. So we subtracted 2 eighths from that simply because that is what we counted once. We counted 2 green tokens here twice because they were also round. So we have to subtract that out, giving us 8 out of 8 minus 2 out of 8, which is 6 out of 8. Which is 3/4. So that would be your overall probability of getting a round and green token. And it's basically an example of not mutually exclusive events. Now I hit pause. I want you to try number 3 and see how that goes for you. Okay, welcome back. Let's go through the calculations of finding the probability that if we pick a token, that it could be square or orange. So first, let's identify the square tokens. As you can see from our diagram, we have one square there, another square there, another square there. So essentially we have 3 out of 8 square tokens. And then we count, after we're done counting that, we count the number of orange tokens. And let's circle them. Get rid of this. All right, so we're going to now count orange tokens, which of course there's an orange token, there's an orange token. Looks like that's all of the orange tokens that we have. Okay, and so 3 out of 8 for the squares, because there's 3 squares out of the 8. There's 2 oranges, 2 orange tokens. So we're going to add those 2 together. So it could be that our probability is 5 out of 8 for us to select a square or orange token, unless we have counted something twice. Now, if you think about this, I've got the orange tokens circled. Let me circle again the square tokens. Here's the square, and I'll do that in a different color. A square there, a square there, and a square there. Have we actually counted any of these more than once? And as you can see, we have a square that's also orange. So there's only one of those, so we subtract that 1 orange token out of 8 from our data, from our probability, which in turn will give us 4 out of 8. If we take 5 out of 8 minus 1 out of 8, which is 4 out of 8, or we got a 1 in 2 chance of getting a square or orange token. Again, it's an example of events that are not mutually exclusive, and it shows you how to subtract out of the probability what has occurred in more than one situation. All right, now try number 4. I'll hit pause and you try number 4. Okay, welcome back. Hopefully you were successful with this problem number 4. We're trying to calculate the probability of selecting a token that's yellow or round. As you can see, I tried to color code this. There's 1 yellow token in our list of options. So basically, we're looking at 1 out of 8 to get a yellow token. And then we have to look at all the round tokens. We got 1, 2, 3, 4, 5. There are 5 out of 8 that are round. Then we have to ask the question, are these 2 events mutually exclusive or not mutually exclusive? And the answer is they are mutually exclusive, which means we have not counted any event more than once. So if this happens, if they are mutually exclusive, you just simply add them together, simplify, and that's your probability, like the previous video indicated. So this last video is somewhat of a summary of everything in section 11.3. Number 4 is an example of mutually exclusive events and how you calculate them. 2 and 3 are not mutually exclusive, where we had to take away events that occurred more than once. And then, of course, number 1 was just your basic probability with 1 event occurring. So hopefully that went well for you. Good luck, and let me know if you have any questions.